Sunday. Okay. Yeah, you can put me down for though. I'll be happy to do it for you.
There's only like 3 people in the session for the scholarship.
I'm surprised they have that. The three. I thought it would be, for graduates, it's hard to recruit. So, yeah, UC Berkeley, they always try to send stuff to me, and also Georgia Tech. But okay, we are gonna talk about investigation process today. I want to take the opportunity to give you exposure to as many software as possible or tools so you can see what that will be like. So in the lab today, we're going to use Linux versions of things. And so you can see the difference compared to last week when we were using things in Windows. But for today, we're going to talk about computer investigation process. We're going to get a little bit more information about like chronological order of things. How do we look at files that we carved? And those type of stuff. Okay, so let me minimize this. Okay, so to start, it talks about how you should be more thoughtful about your investigation process, because ultimately you are searching, right, for information that might be difficult to find. And digital evidence, as you know, it can be modified if you access it a certain way. So we want to make sure that we are looking at the scope of the search, right? And it talk about that here. And then also the restriction that you might have based on the case. And if it's time sensitive, you want to be mindful of that. And also how you would use images. So Mac time, which is part of the first question, it really referred to modify, access, and create. And in regular system, we only see how we edited and saved a file, right? If you open a file and you modify something on that file and you saved it, it would update the timestamp. But in forensic, we would see that the time that the system create that file, it creates a timestamp, right? And even when you open that file without changing anything, it would show as access. And then if you had edit the file, then it will be modified. So Mac time really referred to these processes, and we want to be accurate with the timestamp. So a lot of these software are going to give you that. And what it will also do is it's going to pull the timestamps and it's going to put it in the order, right, of the event, so that way it's easier for you to kind of follow when the user create the file, when they modify the file, when they access the file, etc. So it talks about multiple frames of references. That's going to help us really look at the activity on the system, either by the system or by the user. Okay. And then some of the things that you should look at: event logs, right? File system logs, internet browsing history. That can also capture some events that occur on the system. So for the first question, we can say that MAC or MAC times refer to modified, access, and created times. Those are timestamps that we would see recorded on the system. And in this perspective, right, this is on the image that you're analyzing, right, not the actual system itself. So if you are given a laptop, you want to take an image of it, like what we've been talking about, and then evaluate the image and looking at, right, the drive, like what we did last week, and looking at the files within the drive. So the files that were created, edited, and accessed. And it is important in the investigation process because it gives you records to establish timeline of events or occurrences on the system. Or it could also pertain to occurrences about the user, right? Because sometimes that's gonna give us a better understanding of, you know, like maybe they took a picture, they posted a picture, or they deleted the picture. And the resources that we can use to determine the context of the occurrences to the specific artifacts that will pertain to your event logs. And in Windows, you can go to Event Viewer, you can search for it, right? Like on your Windows search bar, if you've typed in Event Viewer, sorry, you can find that. You can also go to the Computer Management Console. It's also listed in Computer Management Console if you have access to that. Now, for Linux, as you know, you can find syslogs, which really tells you about the logs of the system activity. But you have to dig a little deeper in a different area if you're looking for other types of events. So file system logs is important. That really tells us about like where the files are created, when it was created. Internet browsing history, you can find that in the browser. And also, we are gonna look at this later when we look at like RAM. So we will touch back on this. And this is gonna give you what's called a super timeline, which gives you a better understanding of what had happened on that system. And if you're looking at a specific user accessing that system, then you can also see. So even if they use social media, right, it really pertains to internet access history. So because they are web apps, and sometimes it might not be out of the browser, right? It will be in the app itself. So you will also have to look at the app logs. Any question? Hello. Okay. So we talked about some of the resources that we can use to be able to determine occurrences on the system, and then how we can apply MAC time. Now, one of the tools that we will see, hello, and we talked about this in the past, which is known as X-Ways. And I put a link on your notes. And so if you want, you can check out that tool on the website. And it tells you, it asks you which feature could you use to establish a timeline in the artifact. So for this particular software, you would use a feature called event list. And you would see this when we use our tool today, like Autopsy. You would see that it would allow you to click a button or select an option to chronologically organize all the artifacts that it pulled out from that particular image, right? Like when the files were created, accessed, and modified. So it's going to give you based on the timestamp. So in X-Ways, which is a tool that we would use for forensic investigation, you would refer to event lists. Okay. And X-Ways section is on the bottom of 1, right? It tells you event list right here. And in that, you would see that it would contain timestamps for file system access, browser history, event logs, registry heights, which is really nice because if you manually do this, right, you have to dig into each area and then you have to get into each part of, you know, like a certain application, a certain area of your browser. So that can take a lot of time. So when you capture the image of that system, it's going to try to pull everything. And if you select event list, it's going to organize that for you from, you know, ascending. So it's going to be from the earlier to the later timeline. So it will look like this. So on the software, right, because this is like the image that we kind of, it's similar to what you see with ProDiscover. And at the top, you would see that there would be a button that would have like a little clock. Usually, sometimes you can also find that in the menu option as well. So that way you can be able to organize and specify the information on your report or for your report. So the case that the authors refer to, and I pulled this out of the textbook, we're gonna actually use this case later so that way you can see the image that he's referring to. So we wanted to see like who actually sent the email, right? And so this is what you kind of see, and it's gonna look at the hash value, right? So the hash is gonna tell us whether that file has changed or not, because the first time that that file is created, it has a specific hash value. And if that file is modified, that value would change. So the system or the application is gonna compare the hash value to look to see if there's modification, and if there is, right, the modified time is gonna then be recorded into the event list if you're using X-Way, and then it's gonna be able to pull that information. So the below screenshot is gonna give you something like this. And you can also like click the calendar option where it actually places it in a visual calendar for you, which is kind of nice. So it's gonna give you the timeline, right? And then the information about a specific artifact. So if you're looking at like the executable for Excel here, that's what the notes is referring to, right? You would see, and then the time it's created to the time it's accessed or modified, that will be recorded accordingly. Okay. Okay, so based on that example, we can say that in X-Ways, in order to search for an event that occurred, right, on a specific date and time-based system log information, right, if you're using X-Way, and that will pertain to event lists, you would click the calendar and then you can filter the date so that way you can search for that specific file name to examine the activity. And this is gonna help us narrow down like a specific activity that happens only on that date. Because if you're looking at maybe just an image of a computer itself, you will have a lot of activities, right? From the time that that computer was installing software, or even starting with some of the application usage all the way into the current time. So what we can do is we can filter out some of the activity, and then that way we will be able to see. So if you are looking at a fraudulent case and you would suspect that it would happen in a certain weeks or months, we can narrow it down through the date that is given to us in chronological order. So first, you kind of have to get it to give you all the events that occur, and then you can filter it down to the type of events that you want to evaluate. Understand? So now that the first part, the event list, when it's going to pull all the events and put it in order, that scan is going to take hours, okay? Especially if you have the current monitoring system. But then after that you have that set up, the filtering part is going to be flipped. And so once you have that, you would then take screenshots of it, you would record what you have found and interpret that, right? So the forensic person is going to be analyzing what each artifact really means to the case. And then on your report, you would say that the finding shows, these things, and that might be something that would relate to proven false or negative, false or positive. for that case. So we wanted to make sure. And so that's gonna be helpful. We'll use X-ways down the line. Any questions? Okay, so if you look at the notes, right, it gives you some example on how it would look at the file, how it's created. And then also even in email, again, like what I said, we're gonna look at the email later. So now the email header is gonna give us the information about who sends, who receives, right? And all the servers that take part in forwarding that email. In some cases, you're gonna see the email then also be intervened or modified, or someone else is impersonating that person to send email. You see that with a lot of phishing cases. So you would see, and the software, if you're using forensic software, it's gonna pull the email header and it's gonna give you the information about which email was sent, right? How it was sent, and so on. So some of the software that you can use, right, for forensic, that's gonna give you NAC, right, or chronological timeline. You can refer to Belkasoft, Autopsy, Recon Lab, Paladin, X-Ways, right? A lot of these forensic software, and we are going to use bulk extractor down the line. And you're going to see that they come with that feature already. You just have to know how to use it. So, because based on the standard, you would see that it is, it's made to be standardized for the industry. So you would see some of that. So now in the class, I won't be able to give you exposure to all the software because some of them are proprietary. And then you also have free trial that you can use. So if you want to get into forensic, I encourage you to look at some of the common software and then be able, because the job you're gonna see that they're gonna list the type of tools that they're looking for someone to be able to use. Okay, one of the software that we can use that's gonna be command line based and also it has Python API is gonna be Plaso. I put the link for their GitHub repository. And if you're using it, I encourage you to read their documentation first. Open source software, a lot of times they have some requirements and you have to understand how to use them and how to use their command line. So it's always important to do that. It's using Perl to be able to give you the log2 timeline, which is like a timeline report. And then, but because it is developed in Python, you can integrate it as a Python tool for some of the things that you can use if you prefer to do that. And so if you look at their repository, their source code is available on GitHub. So Plaso information is there. And it is a little different than what you would see. So we would come back to this a little bit. You're gonna see like these functions that's gonna be used in other type of software when we look at like, some memory-based analysis software. But the tools in Plaso, you're gonna see you can export a file, right? Log2 timeline, I think we talked about that. It's gonna give you the chronological events for your files that extracted. In command line, because it is command line only, right? You don't have buttons to click or things to navigate. You don't have a UI. You are gonna have to use some of the main command, which execute the function from the actual program. So like if you want to sort, you have to do a p sort. And then p info is just going to give you additional information about a specific thing. So it'll look something like this, right? And you see a lot of the tools in security, it's like this. It's only command line based. So you have to know how to use the commands, and then you have to know how to use the option, right? So a command with an option, so you're gonna do a dash and then some kind of option added to your command to be able to give you some additional insight. So for number 5, it says, how is Puzzle used? Right? We said that it is a command line interface tool, so UCLI. That means that you can only issue the known command for it, right? So and all software, you can start with the help, and then it's gonna give you some of the common commands that you can use. And then you can also go to their documentation and be able to find out more about how to use. A lot of them, they are really good at giving you a wiki page or how to get started. So go to the GitHub repository. So some of the common tools that you would see, you can export an image. This can be important because we can use the tool itself to, create an image and then export the image. And we can also have a chronological timeline of the logs of activities of the system. So log to timeline, and then p info, p sort, p steal. So you see the bulleted list on the notes. Those are the things that I've added here. But there's more to it, right? These are just some of the common feature that you would see. So now for the command output, what we want to look at this and see. I wanted to kind of illustrate or show you through the exercise how you would use it with Plasso, right? So for example, for number 6, if you use log to timeline command in the command line interface for Plasso, you can run that on Kali Linux, right? That's probably best because it has Python built in, but if you can run it on any system that has Python actually. So you can read their information about how to run and install their software. But anyway, so you would do log to timeline, and then the F here, right? It's going to allow you to add this file. Okay, so F is actually file. And then the entire file name with the extension. So basically, we are gonna use this tool, right, to create a chronological timeline of this file. Okay, and the file is located, right? Actually, yeah, the file is located here. Okay, and then it's going to output that onto the report for Gene 01 folder. So it tells you on the answer here that you're going to use log to timeline to extract Windows text file to, right, this particular location from this image. Now, if you don't have the entire file name, it's going to then throw you an error. So the first parameter here is going to be the destination location, right? So wherever that you want to extract it to, and then from, you're going to be able to put it in the second parameter. We will use Plasto down the line, so you will need to know how to use this. But once you use the command, it's a lot easier, right? Like as if we do it in the lab, so you can see. Any question? Okay, yeah.
It extracts the Windows text file to
So basically, this is a file that exists in this image, right? It's a file that was on the system that was from this image.
Okay.
Yeah. And then once it pulls that file information, it's gonna place it into here, which is its own file.
Okay.
Yeah.
So the first like pathway is like the destination.
Yeah.
Okay.
You want it to be put into Paso itself, so that way if you have more files, it's gonna then give you the timeline or whatever the report that you're gonna use. Yeah, so this file actually exists in Gene01 image. And this is the image that, we get it. So you have to make sure that it's in this location. Right? Now you can see the path, that's a Windows tool here, right? If you install it on Windows, you can run it this way, but with Linux, then you have to make sure that, wherever the path would be for your images and your application, you just gotta make sure you put it in the right way. Okay. So let's move this down. And then in that section, it talks about P info, right? For 7, it says, which Paso tool can you use to get storage information about the file? And how many sessions were used to create it? So we can use P info, and P info is going to give you the information about, where the file is stored and when it was created. So for A, it says in Paso, which option in P sort do you use to output formats? So you are going to do P sort, right? And then you're gonna do, I didn't want it to capitalize. You're gonna do a capital O, right? And then you're gonna do format like this. But there are other options. So the O really represents output. Okay. If you want to output a certain way, then you can specify O. So each of these have specific options, right? So if you, let me see if I can go to their documentation. So this is Paso documentation, and then you can click on how to get started. It really talks about like how do you install if you're using, like Debian Linux, like Ubuntu or Mac OS. If you don't use Docker, so ideally we should run this on Linux systems or things with terminal like Mac OS. And then if you click on P sort, it's going to give you some example, right? Like, so when you run P sort, it's basically a module in Python. If you took Python already, it's basically a Python file that is combined into the actual application itself. So that module would contain the sort function. And so it would run the P sort like this, and then you can specify, right? Like output format, that's what we talked about here. But you can also, after you install the Python software, Paso itself, this particular module would exist. And so you can run it as a Python file, right? Now in Linux itself, some Linux, like Debian Linux, you have to run the Python-m, and then you have to, n indicates the module, and then you have to run, make sure that the it's actually linking to the Python packages. Otherwise, you have to specify a path. So, a lot of times, sometimes documentation, they just assume that you already know that, right? So you just need to be able to figure that out. Now if you want to output like your time zone or other things, you can just follow the options right here, right? The W is going to, you would indicate like how you want to output as a file name. And then if you want to output like a time zone, then you can specify your time zone here, like UTC, for example. And then if you go to the user documentation in general, right, you would see all of the main functions like pseal and some of these. So like I when we use Paso, right, you're gonna see some, I've tested the command so you can implement that. And you just have to make sure that the application gets installed onto your system. You can follow the instructions on how to do that. So if I don't use some of the tools that we have mentioned, what other tools can I use to create timeline for my investigation? You can use a tool called Time Sketch. That's gonna also give you organized artifacts in chronological order. You can also use Timeline Explorer, Timeline Maker Pro. These are specifically made for having chronological timeline of your artifacts. I have a big section on Plazo, but when we use it, you would see. So I put down some other tools, and ELK stack and Logstash. ELK stack is important in cybersecurity, forensic, and other areas. If you do data analysis, that can also be important. Elasticsearch and Logstash, it's really good for pulling log activities and then giving you specific things if you want to be able to analyze statistically or filter out some information. I know Logstash is no longer open source, right? So the L of the ELK is now proprietary. Kibana is also working with Elasticsearch. So I tried to write multiple labs in CIS27A using this. And it's okay, you know, I have to fix some of the issues. But ideally, if you are analyzing Logstash is probably one of the tools that you should learn. Because in the industry now, I think that's probably have a lot of value. And it's made for Mac OS, Windows, and Linux. They have great documentation, so you can go in and be able to read some information about it. You know, when I write the lab, I usually just have them install it on Linux, and you know, I mean, with the quirks that now the L, you know, is kind of missing, so we have to replace that with another type of tool. But Timeline Maker Pro, I give you the link. Time Sketch. You also have Eon Timeline. There are other options that you can use, but these are some of the things, the tools that you will find that will be helpful. And the majority are open source, but not all. Okay. All right, the next part, we're gonna come back to storage media, right? We touch a lot on disk and disk storage. Last week, we talked about file system, we talked about partitions, and we talked about free space, unallocated space, allocated space, and slack, right? So when you work with storage in general, and that can include micro SD, flash drive, SSD, HDD, just make sure that you examine allocated, unallocated, slack, and bad sector space, because the slack is going to give us the deleted stuff that's giving back the space to the system, so you will see remnants of deleted files and items. Unallocated, sometimes you would have hidden files there. Allocated, that just means that it uses for formatted partitions. And then your bad sector space, that will probably be ideal to analyze in the case that you might have some fragment or remnants of something, but bad sector usually is mostly identified and by the system and also might not be usable. So what we want is we want to analyze everything on that list, all the components. Okay, so when you're examining the storage media, you must follow this progression. Okay, there's order to things because if you start pulling things out of order, you're gonna find yourself working harder, not smarter. So first, we are gonna examine the disk. Okay, that's the actual physical disk. So we gotta make sure that we follow procedure, right? And then we document and making sure that we tag the disk. Then when we examine the disk itself, depending on the system, it will tell you like the letter, the drive letter, and then the volume information, right? That will pertain to some logical aspects, like the capacity of the disk, right? If there's any division in the disk, so we would then look at the volume of the disk, what, the logical capacity of it. Then we're gonna move into the file system. FAT16, FAT32. So a lot of your USB, when you did your lab last week, some of you got to the second part of the lab, right? Is when we create the image of your USB and then you analyze that actual USB image, these little ones, right? And you saw that these are FAT16 because they must be compatible with all OSs. So you tend to see FAT16 or FAT32 on the micro SD and USB. So your file system would be important because that's going to tell you the type of device or the type of OS you're working with. So if you have NTFS, then you know that it is a Windows OS, right? If you have EX4, then you know that it's a Linux OS, right? So that's important. And how the system organized the file and the carving process of it would entail based on the file system. How do we know that, right? We talked about the cluster 0, which is it's gonna look at your boot sector and the first sector to really determine, right, the disk information. So if you did last week lab, you saw some of that. And then after we have all the things about the container, then we're gonna move into the data. So that means the type of files that you're gonna carve out. You saw this with the JPEG, right? The JPG, the images that you carve, and then the documentation, the hacker, where was it? The hacker documentation the document that you found. So the data component, and then metadata, these are properties or tags of your actual file that's being carved. So now the application is really designed to do all of this for you. Like ProDiscover does that. We're gonna see that with Autopsy today. So you would see that it's gonna be able to pull that information up and give you that. So we want to follow the progression, moving from the disk, right? The container outward and then get into the item inward into the actual items inside the container. Okay. Okay, so here it talks about each of the areas for the media progression. So the data unit, right, we talked about clusters, and that's really where the file exists to the address location on that storage. For the blocks. Okay, this is very common in FTK or forensic toolkits. I shouldn't say FTK because that's actually software. A forensic toolkit is where you can actually do a keyword search. What if I find like 100,000 files, right? I want to be able to narrow down specific file by searching for a keyword. And you see this with Autopsy and ProDiscover. So you can create your keyword list. Let's say that I want to find NTFS or I want to find FAT because that's going to narrow down, right, the file system for me, or maybe a file name, right, or some user information. So you can customize your keyword list and then apply it in the software so that way you can search for it quickly. Okay, so when you're using a string search, how should you categorize your string search? So we can create a generic keyword list. So that means that we would create something like password as a keyword, right? Or ID, right? Or something like encryption. So those are like generic words that the application is going to use to give you some kind of output. Now that this is going to be more broad, and if you want to narrow it down, and if there's specific case information, right? Like, for example, when we work on the drug dealing image, what we're gonna see is we can actually filter it based on that case, right? So we can say money exchange. That will be like one of the keywords that we can, because that will show up on text, or or maybe it's some kind of tags that we can see on the image, or we can just put money, right? So some cases doesn't have money that's involved, right? But in a case that deals with like money exchange for drugs, then we can have the system search for a specific term. Because there might be images or something that will pertain to it, and then it's going to try to pull that out for you. So now as you make your keyword list, you can name your keyword list so that when you can reuse it, you can modify, subtract, add more to it. So ideally, your keyword list should grow as you go. And then you will have multiple keyword lists, right? So when you do Autopsy with me, right, in the Windows version, you're gonna see that you're gonna do this part. I know CIS27 students, if you took my class last semester, you saw this already. But ultimately, you can have as many keyword lists as you want, right? So, or your list can be long or short. Okay. Okay. So one of the things that it talks about symbols and characters and search criteria, you need to have appropriate. So symbols and characters, some software would prefer or refer to a certain type of symbols for search. So what you would see here is like Autopsy, you can place, right? The symbol that you can use to place any character in search, you just use a period or a dot. Okay. Can you implement a wildcard? Some software will allow that, but some software don't. So a wildcard could be an asterisk where we can have, like, for example, if I don't know the entire file extension, so for example, I want to search dot, but I want to also include dot x, right? So I can put dot doc, right, with an asterisk where the x could be placed there. Some software would be okay with that, and some software can't. But one of the common symbol that you would see where you would place any character in search is you just use a period. So, for example, if I want to search for FAT as in the file allocation table, right, I can also put dot FAT, and that's going to allow it to search for the characters. So yeah, some of the instances for patterns, I put down some of the pattern for you, but know the encoding system that's important. Commonly you're gonna have software that uses ASCII, right? Some of you do programming, so you already know most of the program that we write is gonna be implementing ASCII. Now ASCII is gonna be limited to its character sets, right? Because each of the character represents a numerical value on the ASCII table, like the letter A is equal to 95, right? So now where Unicode also very common, it has a larger character set, so that way you can build a software that would handle many symbols. And you see this with web app too. So for example, I know that they do input validation, so they would prevent you from using characters and things like that. But when you're using a web app and you're filling out a registration form, and then sometimes you cannot use all of the characters that you want to put in, right? Special characters, etc. It's also because if they're using ASCII, it's limited compared to if it's Unicode, then you have a wider set of character. 65,000 compared to 256, right? Huge difference in that. Okay, so here's some symbol information. Asterisk, right? So you can you can use this. So in a lot of the forensic toolkit, you can use this to match the character to a certain amount of time. So you can say CA asterisk T. This is going to look for CT, CAT, CAAT, and so on, right? So now this is a wild card where that's the asterisk is just a placeholder where you can have any character or numeral character in that placeholder. Okay. People say this is a pound sign. The book says it's a pound sign, but that's actually a hashtag. You already know that. But the pound sign is really indicates digital value, right? So if you're referring to the telephone back in the day, numerical value 0 through 9, and then you have a backslash that will be following the character that's interpreted literally, or you would have a caret, right? Little hat. This is going to give you some kind of start with the text. So if you want like anything that starts with 1, 2, 3, right? You would do asterisk 1, 2, 3, right? So if you want to say anything that start with password, then you do caret password, right? So that's how you use these symbols. And then there's more. So I put down some example. You want to match the end of text, you can use the $sign, the plus symbol that's just allowing you to do repetition with the character multiple times. Curly bracket, you can look for preceding characters, brackets, and so on. So you can read that list. It's helpful when you're trying to filter. Now, it depends on the software and how it was developed. Some of them are specific, with the characters that they implemented for the software, but in general, that should be helpful. Okay, even the pipe, right? Or question mark. Now, so this is when, if the security perspective, you would see like database application because they are using these things for, database query and things like that. So through the UI of the app or the URL, they are controlling that. So we should limit it so that way not all characters can be used. So that way we don't come across injection. But in forensic, these characters are used in the application, even with the web app, to be able to give you better analysis and better filter. Okay, if you took programming classes that deal with regular expression, you know this. So basically, regular expression is implemented in a program to make a pattern match. Okay, so for example, Social Security number has different parts, right? You know, so many digits in the front, so many digits in the middle, and so many digits in the end. There's a pattern. So we would do a regular expression by doing something like this to be able to have a pattern for that input and output. So for example, an IP address, right, it would look like this, right? 3 decimal, maybe 0, 1 to 3 decimal, 1 to 3 decimal here, and everything is separated by a dot or a period. So you would see that it would be 1 to 3 decimal, right? That's a digit. So you're gonna have a digit there, and it's gonna separate, as you can see with the slash, right? I highlighted that for you. So this is gonna allow you to implement the pattern for the dot or the period, and then this is gonna allow you to implement the pattern for the decimal digits. Okay. And we would repeat that for each part. And so that's, you know, and in Python, it's the same thing with JavaScript, with, you know, so regular expression is common. I didn't cover this part when I teach Python because, you know, that is just more on like I want to say the aesthetic of the UI, really. In my opinion, it's really UI design. I care more about like the back. So back end development. But if you do JavaScript, when I taught 14A, we focus a lot on this because JavaScript is for UI. So if you take 14A, it addresses this. But this is good to know, right? So it's called regular expression, and it's used to implement pattern for numbers or characters or even strings. Okay. All right, let's talk about files that we need to find, and that's the next section. So 14 asks you, how do you find the deleted files on an NTFS volume? So like on your Windows 10 right now, right? And we talked about this continuously. When you delete a file, you know, it might go into the recycle bin. And then when you empty the recycle bin, in a Windows system, it actually put that address for that file where it used to be, right, back into the list for the system to use, right? So basically, it was on a certain part of your disk, which has an address location. Now it has given back to the system, right? It makes that address becomes available again. It's kind of like, you know, how you used to live in a house, right, on a certain street that has an address, and now you move, right? But that house is still available, and if someone looked you up, it will still show that you used to live there, right? So now we're the people who are looking that up. We're going to look up where that file used to be. And so it would show up with the $sign, and it would show up as an MFT file entry, which puts back that address into an unallocated cluster, which is not being used. So when we say allocated, that means that it's used by the system for certain things. Now the file is deleted, that space has now become unallocated, right? And the existing MFT will be incremented up to 1 based on its created. So it's gonna add to the next. So it's saying that it's incremented up by 1 based on as it is created. So if the address, for example, remember how I had you look up the address? So let's say it was 1000, that's where it was, right? Once it's deleted, that MFT, it's going to show $MFT, and you saw this. I know you did because you screenshot it, and I just graded your lab, right? And then it's going to give you the next one, which is 2000, right? So it's going to then show the next allocated space. So that way, the next file that's gonna be created can use that space. But it shows you where it used to be. Okay, so where can I find this information? There's even some screenshot, right? So recovering deleted data, and this is big money for forensic industry. So, you know, people pay a lot of money for this, okay? So the first character of the directory entry will have changed, right? So it would change to hex E5, where the file allocation table entry resets to 0, because when you deleted it, it's gonna then reset to hex 0 because it used to be at hex E5. And then the file system reads the directory and it encounters hex E5, it would then skip the entry and start reading it from the subsequent. So it incremented down, so because it was at hex E5, right? But because it's deleted, it resets it to hex 0. So when it goes back and find the file again, when it gets to that location, it's not going to be there anymore. So it's just going to go to the next location. So to recover the deleted files, we would then reverse the process. And it tells you the file system used deleted files. So remember that it has not changed in the file content. So that means that if the file was at hex E5, it would still be there. But because it's deleted, it's reset, right? It would go to the next location. So if we reverse the process, we have to go back to hex E5. You understand? So that means that we have to go from the incremented address back to the file location to be able to read it. So now if you reverse engineer it, because the file allocation table, it has that entry, it incremented by 1. So you can find it using the first cluster. You saw this, cluster 0. Why? Because when it resets, it puts that information in cluster 0. You saw this when you click on that 0, red 0, and you saw the $MFT, and it tells you what files it was deleted. Right? So now you can see why, because the software simply just do the reverse engineering part, and it's giving you that when you, so we always go to the first cluster, right? The first square, we click on it, and that's going to give you the file size, right? The cluster on the volume. Okay. Okay. Now that's NTFS. Okay, for FAT, it would look something like this. So file allocation table, organized file a little bit different. So it's gonna start with hex 00, and to the end it's gonna be like FFFF8. These are hexadecimal, right? Or FFFF0 if you have a larger file. So it tells you that it does put the new file in place, but it does put the use space, or the space that file used to take, right, back into the space where the directory where it can reuse it. So that means that you can, when you replace the character where that file used to be, let's say that it's hex E5, then the directory, you will not be able to find it, but you can still look up short or long file name. Remember, we know that if it's like a tilde, then it's truncated file name. That means that it used to be a long file name. And then if it's showing a short file name, it's a 3-digit or 3-character. So when you change the hex E5 value into a short file name entry, you can use it as a replacement character for the subsequent. So what you can do is you can implement a way to look at it with a short file name first, right? At the location where that file used to be. And how do we know? Right? We would also go back to the original cluster, which is cluster 0. to be able to, that's the start of your file table to be able to see. Okay. And then the MFT information for question 14, you would see that here. So I encourage you to read through this, right? And it kind of ties back what we looked at in lab 4 and what we also talked about in lab 4. So if you are doing USB analysis, which you will be doing for your final project, you will see that you're using file allocation table, which is the FAT, right? It's still going to give you the squares that you see on the software, and then you have to kind of look at where the file used to be or the file. So I will give you a USB. There will be files on that USB. There will be hidden files on that USB, also deleted files on that USB. And your objective is to find as much information about that USB as possible, right? You're going to write up a report, and based on your report, that's going to be your project. Great. So, and then I will give you more details about the project when we get to like week 10. So you should have like 6 weeks to work on it. Don't wait till the last minute because you won't get it done. All right, any question? Okay. So short assignment, short note. So have some time this weekend, read through it carefully. And then also there's a homework assignment this week for your quiz review. We will have a quiz on Canvas next week. I don't do in-class quiz because it makes students do it. So you will have the whole week to do the quiz that's short. And then your best score out of 3 will be reported. Okay, so let's stop.